Welcome back, gangies. We're back once again for some more LeetCode to be done. As you know, it is Friday, so we don't have a ton of time today, but we're going to try and get what we can done. But we have about 30 minutes, and yeah, trying to get it done before work, so this is how it is. But yeah, so this is where we're at, and I think we do have a comment. Actually, let me just check real quick. I think we do. Oh, but yeah, we're comment by Aurelius. Legendary profile picture. Floor with a futon is fire. Highly recommend. Yeah, we might have to do that. Floor futon. I slept on the floor with some basic sheets. Looks fire. Might have to go full Japan mode and hit the floor futon button because it is fire. So the Japanese people have really figured it out because I think it is the ideal sleeping position. So yeah, awesome comment, and yeah, I think we might have to try it, but we'll have to see how it goes. But yeah, I'm excited to see if we can make that make sense. But I think that's where we're at, and we do have some problems we were doing yesterday. We're kind of busting through the easies. There are some that were giving us some troubles. So I think that's what we're going to try and do today. We have binary gap, which I think we're unable to figure out. So I think we're going to spend some time doing this one today. I think what we didn't account for yesterday is that it's any of the indexes. I was only working with the first and the last bit, which was creating an issue, and they must have a 0 between them. If not, then their distance is 1. Here we return 2. So if we sliding window over this, we'll pretty much keep going forward until we find a 0. We'll always be expanding the window, which is going to be our for loop. But where the start of our window is probably where we're going to modify. So if this is always moving forward, then we can keep the start of the window once we find our first one. Calculate distance between these two ones. We want the longest position. So once we find a second one, we would reset our start until we find another one. So if that's the case, the least significant bit is going to be where the window starts, which is 0. It's actually going to start at -1. So if window start equals -1, then we can set window start equals -1 and 1, right, equals 1. We'll set window start equal to I. Otherwise, if and 1 regularly, I guess this is kind of a modification of the other one. If and 1, it means we're at a 1, right? If window start isn't set, then we should set that. If it is set, and we found another 1, then we should take the difference between those. So then longest would be equal to the math.max of longest and math.absolute value of I minus window start. And then we could just say window start would now be equal to I again. And then we could say n is equal to n bit shifted to the right 1. So one issue is that we need to make certain that the we need to make certain that the we need to make certain that we need to make certain that a 0 exists between them. If they're right next to each other based on the current logic, we should get 1. If they're not, we have 0, 1, 2, right? 0, 1, 2, 3, 4. We do 4 minus 2, and we would get 2. I feel like this should work. It's a small change from the other one, except we're now considering all possible. Yeah, that's awesome. So feels strong. Yeah, I realized now I was seeing this problem as something it wasn't, and I continue to do that while keep treating a problem like it's a different problem, and it's not, and I should just treat it as for the problem that it is. That being the case, I might not have been the only one, since this problem has an extreme number of dislikes. So we have count good triplets. Have we done this before? Given an array of integers r and 3 integers a, b, and c, you need to find the number of good triplets. The triplet r sub I, r sub j, and r sub k is good if the following conditions are true. Absolute value of r sub I must come before j, and j must come before k. The absolute value of r sub I minus r sub j is less than or equal to a, and the absolute value of r sub j minus r sub k is less than or equal to b. And the value of r sub I minus r sub k less than or equal to c, where bars around x denotes the absolute value of x. Return the number of good triplets. So these things must be true. So given an a of 7, a b of 2, and a c of 3, we have I, j, k. We have 3, 0, 1, 1, 9, 7. There are 4 good triplets because r sub 3 and so we're saying index 3, 0, 1, 2, 3, 1 plus 0 is 4, which is less than a. One plus 3 is 4, which is less than 7. Then we take 3, the absolute value of r sub I minus r sub j. So r sub I, pretty much the difference, the distance between the numbers. R sub j is index 3, 0, 1, 2, 3, which is 1. 1 minus 3 would give you 2. Absolute would give negative. 1 minus 2 would give you negative 2. Absolute value would be 2, which is less than or equal to 7. And then we take 2 minus k. and then the k chosen was 1. 2 minus 0 is less than b, and c get 2, yeah, which is less, okay. Hmm. Three zero 1197. Three zero one 301 311 011. I think you could brute force this actually. Yeah, I think you could just brute force this. Couldn't we just go over the array 3 times? We'd have k here, and since they all have to be, they all have to not be each other, so they all have to be before each other. So instead of starting j at 0, we'll start at I plus 1, and k will start at j plus 1. And then can't we just add these values in here? We'd say the math.absolute value of r sub I minus r sub j is less than or equal to a, and this one will change to j and k. This is I, and it should be I and j and k. Then we have k, I and k. if we ever have to do a problem like this and not brute force, I think we will be in trouble. But so given an array of points on the xy plane given an array of points on the xy plane given an array of points on the xy plane, okay, where points of I is equal to x sub I, a tuple of x sub I, y sub I, return the area of the largest triangle that can be formed by any three different points. The largest triangle that can be formed by any three different points. Area of a triangle I'm thinking a squared plus b squared equals c squared has to do with the not the surface area, like the length of each side. Wouldn't it just be base times height over 2? 5 points are shown in the above figure. The red triangle is the largest. I don't understand. They're giving us 5 points. We don't have the length of the sides. We don't have the length of the sides, we have the points. So if we want to figure out the largest triangle we could make with these points are shown in the above. we would just have to take the maximum of the x and the y. I feel like that would give you 1 and 2. The points can range from anything, basically. And wouldn't that also have to be a valid triangle? For example, if I just took 0, 0, there's no triangle there. We have 0, 1, just a triangle, and then we have oh, 0, 1 would actually be here. 1, 0 would be here. We'd have 0, 2, and 2, 0. Be 2 times 2 is 4 over 2, which is 2. Now, those are the points, but what if what if the points we're looking at weren't part? I think what we need to do maybe is if we need to take an anchor point, and one of our points needs to be above that anchor point, and one of them needs to be and our points, our anchor, our other 2 points should be greater. The other 2 points should be great. Pretty much the other 2 points should make it a valid triangle. So if our anchor point is this, to make it a triangle, the point above it that we select, the x, has to be the same as the anchor point. And then for the point on the right-hand side, since we're making a right triangle, or I guess we could also make other kind. I guess we can't always assume that it's a right triangle. I think it just has to be greater. So I don't think it has to be on the same y, but I do think though x has to be greater. And for the point we choose on the left, the y has to be greater. And I think we end up with a triangle somewhere like that. And we'll say, how do we know if any point can be the anchor point actually? But to kick it off, the point that we'd like to consider, I guess the first point would say if point sub I sub 1 is greater than point sub anchor sub 1, then we would be in business, and then we could do another loop. This one we can just call J. Right, and we'll say if anchor does not equal J and J does not equal I, and point sub J is greater than point sub J sub 0 is greater than point sub anchor sub 0, then you could say area is equal to point sub I right. When you get once you get the anchor point, we're looking for the point to the left first, which has to be above it. That's why we're checking for sub 1 here, and for when we're looking for the right endpoint, we just have to make sure that its x is greater than it, so that it's a valid triangle. But the y can be anywhere, I think. So it'd still be a triangle. Even if that's the case, I'm pretty sure the base times height thing over 2 only works for right triangles, but we'll try it anyway. So we'll say point sub I sub 1 times point sub j sub 0 divided by 2. And we'll wrap the whole thing in a max of area or that. Looks like we might be missing a curly brace. So we have 4, 6, 5, and 3, 1. We're definitely not only using right triangles. So I think we need the way to calculate an area from a triangle. I'm going to search that up real quick. Or I guess I can just search it up on my phone. It looks like there's a method to do so. I mean, it looks like there's a formula, like method formula to use. So I think we'll try that. And then I think we should just have to plug that in right here, because I have no idea. I tried to assume that every triangle is a right triangle, but it's not. So what can you do? But I think that's where we're going to stop for today.